Good morning, KubeCon. For most companies and most of us, the question is no longer if we're going to use AI, but how we're going to do it in a responsible and scalable manner. Proprietary and fragmented solutions really dominate today, but as history tells us, it's really with open source that technology can be democratized and where innovation truly accelerates. We're able to build common frameworks, we're able to iterate faster and go from development to production much quicker. Today, this week even, you've already seen the announcement of the AI Conformance Program on Tuesday, really setting up a technical standard for running AI applications in Kubernetes clusters. But where do you really start? You've already seen, adding GPUs is not really the only thing you must do if you can find them in the gold nuggets of the AI rush era, but you also still need to set them up. You need to efficiently use them. Oftentimes you have different GPUs, very heterogeneous environments, and how do you set them up and make them be performant for your applications? How do you efficiently use your capacity throughout the world? And how do you keep your costs in check? Today, I'm here to talk to you about two sandbox projects that have been working tirelessly together. The first one is KAITO, the Kubernetes AI toolchain operator, possibly the simplest way to run and serve AI inferencing in Kubernetes. It does so via a workspace construct where you can pass on your model and then defer all the GPU provisioning tasks to its GPU provisioner. You can also ground your model using fine-tuning and rack capabilities and parameters that it provides. The second one is KubeFleet. KubeFleet allows you to intelligently place workloads anywhere in the world across Kubernetes clusters. In the context of AI, it helps you find GPU capacity and place your models there wherever they are running. If you pair these two projects together with things like an inferencing gateway, you can now serve models, place them anywhere in the world, and route to them efficiently based on metrics like performance, for example. But let's take a look at what this looks like in action. So today, I have for you an architecture that has 3 Kubernetes clusters, and the first 2 we're going to be running for inferencing, and the last one will run our inferencing gateway and our application. All of this is managed by a KubeFleet hub cluster. Let me break it down a bit more for you. The first 2, we're going to be running 2 different inferencing models. We're going to leverage KAITO to deploy DeepSeek and 5.4. We do this with the aforementioned workspace content. So on your screen, you can see that DeepSeek in that blue box is what we're going to be deploying, and the similar thing we're going to be doing for 5.4. And then on the resource placement that you see there, you're going to be able to see that we're picking a cluster that has the production label. So both of our inferencing clusters have that label. Fleet's going to take care of picking the right one and giving it for us. Then we're going to be deploying the inferencing pool, which in a nutshell is a specialized Kubernetes service that allows our inferencing gateways to point to the right models. And we're going to do so with a Helm chart deployment, and we're going to pass on the labels that our models have, that the KAITO workspace manages. So you can see the labels for both DeepSeek and 5.4. And we're going to use Fleet to place these inferencing pools in the same clusters as the models themselves. Finally, we're going to add our familiar gateway API constructs, such as an HTTP route, that will route to the right models and will be deployed in our gateway. We're going to be using Istio, and we're going to create routing that is based on an HTTP header for each selected model. We're going to place this specifically in that gateway cluster that you saw on the very right-hand side. And to wrap up, we will deploy our application, which is comprised of a semantic router and a LLM proxy. The semantic router essentially does content-aware routing. So in this case, we're going to be forwarding math questions to DeepSeek and all other general-purpose questions to 5.4. And we'll deploy then our light LLM. This will allow us to test this routing across the world with our models anywhere they are. And the first question is the area of a square, which, as you might expect, will be answered by DeepSeek. And the next one is the color of the sky, a more general-purpose question that will be answered by our 5.4 model. So as you've seen, in about 5 minutes, we were able to put together this architecture serving models from multiple regions in the world where I had GPU capacity. And with 5 minutes more, if we had them, you could set up these Kubernetes clusters in any capable provider if you wanted to. These projects are all available today. You can check them out, and so is this demo. All the code and everything we did is available today online. You can check with the project maintainers across in the project pavilion or the Microsoft booth, and I can't wait to see what you build with them. Thank you.